Let's explore LDAP modify now that we've looked at both LDAP add and LDAP delete. As promised, LDAP modify performs the functionality offered by both LDAP add and delete. So you can use this one tool as your all-encompassing tool for adding, modifying, and deleting directory information tree items. So with that said, let's create a subsection labeling it LDAP modify. The name of the utility is LDAP modify, and it features functionality found in LDAP add as well as LDAP delete, and of course LDAP modify proper. The ability to add, delete, modify objects to or in your DIT manipulates objects in directory information tree. Now, we did remove most of the objects we created. We can confirm as such using LDAP search from the command line. Let's execute as such. And as we can see, only the base DN remains. Let's confirm that the remote system by way of slurpd has also been updated. This is the Red Hat slave system, and it too has been updated. It only has the base DN configured. And let's check in with a box we haven't checked in with for a while, the Solaris box, and it too has been updated. So all three systems have been synchronized to reflect the lone base DN record. So slurpd is doing its job from the primary LDAP server. It's replicating the changes to the other two systems, but as we've mentioned, the sync REPL is a newer means of replicating LDAP data between LDAP partners, and we'll be looking at that methodology momentarily. So on to LDAP modify. Now, of course, we have built our tree to a point, not terribly complex, but we've built it with multiple objects, more objects than depicted here, only to tear it down using LDAP delete, which means we'll use LDAP modify to build it again, tear it down again, rebuild it, and make some changes. After all, that's the whole purpose of using the tool. So let's define some tasks. 1. Rebuild the DIT, which means to recreate the top level organizational units, people, engineering, and sales with their objects, their user objects. Now, no need for us to retype all of the information we've typed in. We have the information saved. We've got users defined here. We've got to add 5 users to engineering and sales OU. So together we should be able to reference a handful of files to repopulate the DIT. Now, from the shell, on the primary host, if we navigate to the LDAP subdirectory, we will find a file that we can use to populate the system. Let's find our Linux CBT SUSE 2 window. We'll need to SSH in again. And we're in onto the LDAP subdirectory. And this file, add_3_OUs.ldiff, contains the directives to add the 3 top-level organizational units: people, engineering, and sales. So using LDAP modify will perform exactly that. The syntax resembles the following. Obviously, we need a DN or a root DN to connect to, or a legitimate DN to connect to the system. That should go without saying. So let's indicate the root DN. This is how we bind. This is our bind DN, which is equivalent to the root DN. This is how we connect to the LDAP directory information tree as a user who has permissions to make changes to the tree. Additionally, we want simple authentication. We want to be prompted for a password. And we'll turn on the key option lowercase a. This is the key option which indicates to LDAP modify that we intend to add information to the DIT, as opposed to modifying or deleting information from the DIT. Followed by -F, which indicates the file that we're interested in importing. But just like with LDAP add and delete, LDAP modify will accept changes on the command line, which we'll look at shortly, via standard in. But it's usually more convenient to make your changes via a file after you have perfected the file, or perhaps have exported the changes from some other DIT, keeping the LDIF format intact and running less of a risk of corrupting your data. So the file is add 3 OUs. Let's just get its name again from the shell. Add _3 OUs.LDIF. If we want to see what's going on, it's a good idea to turn on verbosity -V. So first step is to create top-level OUs and users per OUs. Let's try this from the host. It prompts us. Simple ABC123 will do the trick. And we can examine the output. We see that the people OU was added. Engineering OU was added. The sales OU was added. And the LDAP modify completes by echoing that the modification to the directory information tree is complete. And echo of the exit status returns 0 as we've anticipated. And if we rerun LDAP search, we will see the 3 OUs. So now there are 4 objects, the base DN, as well as the 3 top-level OUs. So we're slowly rebuilding the tree from the perspective of this graphic. Now we need to import the users that belong to the corresponding OUs that we created. But before doing so, let's just take a look from the LDAP browser as to the current state of affairs. If you recall, when we just reloaded the DIT, we were unable to expand or see anything beneath the contents of the base DN. Now when we reload, however, well, our connection's been lost, so we'll reconnect. When we do reload, we will see the base DN as well as the 3 top-level organizational units for sales, engineering, and people. The host is Linux CBT SUSE 2 with a CN equals manager. As we've mentioned earlier, the user ID, oddly enough, is case insensitive. DC equals internal, Linux CBT internal, followed by ABC123 as the simplistic password. Now we've connected, and there we see the 3 top-level OUs, albeit with no subordinate objects like users and or groups, but nonetheless they're there. And if we'd like, we could make a change. We could change sales to, let's say, sales 2, and it would inherit the new name. And here it says it threw an error. If we show details, it gives us a naming violations. OU modifications are generally not as straightforward as they may seem. So it's generally not a good idea to make those sorts of changes using a graphical tool for running the risk of changing references, RDNs, and so on. So the OUs are in place, but how about the users that we spent time creating? Well, we have the add 5 users to engineering and sales, and we should also copy a block of 5 users to populate the people OU. So let's take 5 users, the first 5 users, paste them into this unsaved document. Or in fact, let's just create a new document in the event that we want to use those CNs, those distinguished names, to remove items using LDAP modify. And then we'll change the organizational unit from OU equals engineering to OU equals people. So let's search and replace using Control R. And replace all 5 instances. Now we'll copy the contents, return to the add _5 _ users to engineering and sales, and then paste the new 5 users towards the bottom, and then we'll save this document. Obviously the document now adds to 3 OUs as opposed to 2, but that's besides the point. Let's close this third document. It's no longer necessary, or third buffer, and then attempt to add as our second step the users. So we'll LDAP modify the -A option, and obviously we simply update this to the name of the file for adding the 15 users to the 3 OUs. Return to the shell. And before committing this add of the 15 users to the 3 OUs, since we do have slurpd in place and we mentioned that the replication is on the order of 5 seconds, it's actually 3 seconds by default, not 5, but nonetheless it happens quickly after changes have been committed to the DIT. Let's just confirm that our 2 replicas, the 2 other boxes, have received replication, or have received the latest version of the directory, meaning the Red Hat and Solaris boxes. So we'll find our shell with the Red Hat box, which is this one, serve4, a cat of etc Red Hat release will confirm as such. And then we'll rerun LDAP search on this host. And again, without restarting LDAP on the slave, we see that it now contains, instead of 1 item, 1 entry, it contains the base DN and the 3 top-level OUs. Let's find a window with our Solaris box. That's this one here that we can find out by catting etc release, the traditional Unix file, Solaris 10.10.08. And on this host, we will rerun LDAP search, and there we see the changes have propagated all during our discussion. So replication takes place very quickly. However, there is a more efficient means of replicating using the syncRepl process, which is more reliable than slurpd, but slurpd is still included with OpenLDAP for various Linux distributions. It's no longer included, by the way, with Solaris's OpenLDAP distribution. The package we downloaded from sunfreeware.com does not include an instance or a binary for slurpd due to it being deprecated and succeeded by the syncRepl process. So we can reintegrate syncRepl into the Linux environment, since Solaris, or at least the Solaris package that we have, seems to be ahead of the curve in that regard. So how about adding those 15 users? Well, we can do it from the primary host, or we can do it from our local system by indicating the remote host. Since we have the file on our local system, let's just navigate into our local system to locate that file. We will then specify the remote instance. Let's navigate into old pwd, and we should see add 5 users to engineering and sales. This is the file. So we will paste, followed by the name of the file. Add 5 users to engineering and sales OUs. Now we do need to specify the host, because this file exists on our portal system. The portal system, this box, is not an LDAP primary or secondary server. So we should also tack on, let's just include that. So -f followed by filename.ldif, and optionally followed by host if we're not logged on to the host, primary LDAP server, which in our case is Linux CVT SUSE 2. Let's go ahead and give that a try. And once we've authenticated, we should see the settings replicate, first to the primary and then to the secondary. Here are all the steps that we've run through very quickly. We can echo exit status to get a sense. It's 0. And now on the primary host, we will rerun LDAP search, which should be in our history, where we now see that we have 19 entries as opposed to 4 entries. So the settings have been propagated to at least the master, and will eventually be propagated over to the slave servers. Now before moving on to executing LDAP modify and delete mode, let's just confirm that at least one of the replicas has by now received the updates. It's within that 3-second period. Let's check the Red Hat Enterprise box. Notice it currently reads 4 entries. By now it should read 19 entries just like the primary. And it does, so it has received the records. Replication is in place using the deprecated slurpd. Let's move on. So again, LDAP modify can be used to add, modify, and delete. We've shown you how to add. We've repopulated our schema. Our schema now resembles the extent that we took it to. Let's take a look at it graphically. In OU equals people, we've got 5 users, ditto in engineering and ditto in sales. We can modify values for any of them. The DIT is back up and running. How about deleting entries, deleting users? How about modifying users? Either way, we can update the DIT using LDAP modify. Let's take a look first at modification. So the next task, modify attributes. Usually you modify subordinate objects like users and or groups as opposed to organizational unit containers, because modifications of OUs tend to have wider reaching effects. So as a result, OUs tend to be planned out properly before implementation and seldom, if ever, change. So changes that are usually impacted on the DIT or made to the DIT typically impact subordinate objects like users and or groups, such as a user's phone number changing, telephone number of Linux CBT3 in one of the OUs. Here's the people OU. Let's focus on the first OU in our depiction and any item that makes sense to update. So for example, we could update the user's email address, changing it perhaps from Linux CBT1 to simply Linux CBT1 user or Linux CBT at Linux CBT.internal. Any of the fields that are likely to change can be changed very easily using LDAP modify. Let's go back to our notes and set up an example. LDAP modify, and you can, by the way, modify directly off the command line, but it makes more sense to do so through a script because generally you need to specify multiple entries. So we call LDAP modify in a similar way. We bind to the DIT using the bind DN or root DN. That's a given. We connect using simple authentication. We want to be prompted for a password. We also want to connect to a specific host, Linux CBT SUSE 2. We may optionally want to turn on verbosity and then indicate that we'd like to reference the changes from a given file name. In the interest of saving time, we've created a file name, or a file that is, with modification entries. Let's take a look at SUSE 2. Well, LSL, grep case insensitive for modify, and we've misspelled grep, which explains the error. And here we have 2 useful files, modify_user.ldiff and modify_user.ldiff, modify_delete_user.ldiff. Notice the suffix has an extra F. That's irrelevant. That was simply a naming mistake. Let's cat the contents of the file, and we'll paste the entries into an empty buffer in gedit for discussion. So the modification syntax is slightly different. We do indeed specify key attributes. If we want to modify a given user, such as user Linux CBT1 belonging to the people OU, we indicate the DN followed by the change type. So what is required is similar to LDAP delete or LDAP modify with the delete option, and that is the distinguished name of the object that you'd like to effect changes to. So the change type is modified. Now, LDAP modify supports multiple change types, including add, modify, and delete. So we need to be clear with what we'd like to do to a given record. In this case, our intent is to modify one or more of the attributes pertaining to the user Linux CBT1. So supposing we wanted to update the user's telephone number from our actual corporate number to some generic 888 number. This is how we'd do it. We'd indicate the DN that's unique to the user, a change type, one of add, modify, delete, the field or attribute to replace, followed by the new value for the attribute, or the attribute name colon followed by the new value. If you want to effect multiple changes, separate your changes using a hyphen as you see here. So what this effectively does is modifies the user Linux CBT1's telephone number followed by a replacement of the user's department number as a second option. So this will affect two changes. Now let's just confirm the current values for those attributes, telephone number and department number for the user Linux CBT1 using LDAP search. Here's the output. Let's scroll up to Linux CBT1 in the people OU, and there we see the user's telephone number has a 203 prefix. The department number is set to development. This will change to engineering, and the phone number will change to an 888 number. Let's go ahead and specify the execution of this process using our LDAP modify that we have placed into our notes. So we'll take this LDAP modify and simply reference the predefined file on the remote system. And that will be a modify user, LDIF, double F's irrelevant, has no bearing. And the host is localhost, but it doesn't hurt if you specify the host, even if you are on the local host. There we see, because we have verbosity turned on, the modification, the replacement of the user's telephone number with a bogus 888 number, as well as the replacement or update of the user's department number to engineering. And the entry that was modified is this particular distinguished name, CN equals Linux CBT1, the people OU in the base DN, followed by status information, the fact that the modification was complete. And it's always good to echo the exit status to get a sense for whether or not the process behaved as expected, and in this case it did. Now the ultimate test, of course, is either using LDAP browser and or the shell to determine whether or not the user's attribute has been updated. So let's reload via LDAP browser since it's graphical. We'll swing on down to the people OU and examine the contents of Linux CBT1, where we see the telephone number has been updated and the user's department number has been updated to engineering. So LDAP modify has behaved as expected. We can also add values for other supported attributes and modify multiple other values. So for example, what if we wanted a wholesale change of email address, department, as well as telephone number? On the remote system, we'll modify the modify user's LDIF file, and we'll indicate a third field. So change type telephone number, let's change it to the original number. Replace department number to, let's call it simply administration, and replace, as we've mentioned, in addition to telephone number, department number, the email address. The email field, if we take a look at the browser, is simply called mail. So this becomes mail colon and whatever the new address happens to be. So back to our text file. Mail will now be, let's say, or include 1@2.com, which is, of course, is bogus. But just for our exercise, let's Control O. And if there are any errors, LDAP will complain. Now we'll rerun the LDAP modify. and now the modify has been completed. An LDAP search will reveal as such. Let's scroll up to Linux CBT1, where we see that the user's values have been updated: telephone number, department number, and mail. So making these sorts of changes via script is very straightforward. Just reference a script. Note, it's easier to reference modification changes via script or via text file than on the command line. But that doesn't mean we couldn't effect the changes via standard in. We certainly could. Let's find an instance and make the changes. Supposing we don't want to replace telephone number, so we'll remove it and simply replace the mail address. So let's update the field mail and reset it to Linux CBT1 at .internal. And this will be, of course, the mail field. These changes will be supplied via standard in, which means on the command line. That means when we execute LDAP modify, we will not indicate the source file or the file that contains the items to carry out. We simply indicate as follows: authenticate, and then LDAP modify waits for us on the command line as expected. Control-Shift-V to paste the items, Control-D, and if there's any syntactical errors along the way, then LDAP modify will complain. So perhaps with the mail address, it threw an error because it wasn't protected, which is why, again, it's a good idea to make these sorts of changes via a text file as opposed to on the command line because of interpolation issues. But if we clean this up, protecting, for example, Linux CBT1 at or the email address with quotes, as well as the distinguished name, then we should be okay. But the change can be effected from the command line pretty straightforwardly, so long as you use the right escaping characters. But again, our advice to you is, even if it's for a single change, make it via a supplied file or use a tool such as the LDAP browser. And for wholesale changes, then unquestionably you should be using a text file to supply the items to the LDAP modify program. Now our last task is to simply show you how to delete items. The syntax is very easy to follow. Obviously it's LDAP modified with the bind DN and the common options: X for simple authentication, W for password authentication at a prompt as opposed to standard in. The host, well, since we're logged onto the host, it's unnecessary, and verbosity never hurts but always helps. So far this is what we need. However, we update the change type after each DN to reflect the fact, or we update the change type for the wholesale change once over, that is, to reflect that it's a delete as opposed to an add or a modify. So note, simply update change type in supplied file to delete. And of course we have a predefined example in the interest of saving time. Let's grep all files with modify and then cat the contents of modify delete, where we have a simple example of an attempt to delete. The distinguished name, including the full prefix of DN:, is indicated. LDAP modify needs to know the precise distinguished name of the object that you'd like to delete. That's always important. No differently than a relational database that needs to know the exact unique ID, perhaps a counter or some unique ID associated with a given user in a relational database, or a given record in a relational database to be removed. The change type gets updated to delete, and providing LDAP modify has the privileges and is able to find the object, it will delete it. With that said, let's copy our LDAP modify command, and of course this time referencing the delete LDIF file. And since that isn't the exact name, we'll omit copying it and reference the file from the command line. The precise name is modify delete user LDIF. Again, it prompts us as expected. And there we see the delete was completed successfully. The exit status tells us as such. The entry is now gone. An LDAP search will of course confirm that the user Linux CBT1 from the people OU no longer exists. We should see Linux CBT 5 followed by Linux CBT 2. 5 is from the sales OU, 2 is from the people OU. The objects are returned to you in the order in which they were inserted into the directory information tree. So the user 1 is gone. Now supposing we try to delete that same user again. That certainly won't be possible because the user no longer exists. It causes the utility to throw an error. It matched the DN of the organizational unit, but it was unable to find the user. No such user. So it knows where to look. It knows what branch to search, but it couldn't find the user. Back to the LDAP tree, if we refresh it, we should see that in the people OU no longer exists the user Linux CBT1. So the key to deleting using LDAP modify, unlike LDAP delete, is simply to update your supplied file with the distinguished name with the DN : prefix, followed by change type : delete. That is the key to making the change, which is a delete, of course. How about re-adding that user? Well, if we use LDAP modify, since that's the mode that we're in, followed by add, this will add 3 users to the OU. Well, these are the 3 OUs. We need to add the 15 users or specify that file. And we should have it in our history. And we should find it on the list. Let's check our local system. And there it is. This file contains the 15 users. They may be wondering why add 15 users. Well, if you recall, we mentioned that we can execute LDAP commands causing LDAP to continue in spite of an error. Let's run LDAP modify -- help. Right above the bind DN we see the C for continuous operation mode. So if we run it in that mode, then the errors will be ignored. Let's just include -C, and this will be to add 5*. This will ignore errors and continue, or by continuing. So at some point in the process, LDAP modify will be successful, but at every other point it will be unsuccessful as far as this particular file is concerned that we're supplying it with. Let's include the host because we're on the local host. We want to effect these changes to Linux CBT SUSE 2. And the file is to add 5 users to the engineering and sales OUs. And this runs through, and when it finds the user that does not conflict, the return value at that particular point is successful. And we'll scroll up, and it goes to modify. Linux CBT1 was modified successfully. Everything else already exists. Now let's confirm with an LDAP search. And we see that the last entry is indeed the user Linux CBT1 from the organizational unit people. So with that said, LDAP modify can be used to add, delete, as well as to modify subordinate objects as well as primary objects like organizational units throughout your directory information tree. Along with add and delete, we'll be using modify throughout our studies of LDAP.